This is section 6.6, and this is about graphing when we do have a phase shift. The phase shift happens inside the parentheses, inside the argument. So in this, we still have the basic things. We have an amplitude that is the absolute value of A. Period is 2 pi over W. Phase shift is phi over W. So if we are doing this, there's a couple of things that we have to do. So if you were asked to find the amplitude, the period, and the phase shift of this function, you always want to factor out the two. Factor out the two. So when you do that, you have 2 parentheses x minus, you're going to have pi over 2, right? Okay, so your A is 3, your W is 2, your phi is pi. And so we have to do 2 pi over W. So 2 pi over 2 that we factored out. So our period is pi. The phase shift is phi over W. So we divided the 2 out. Remember, when we divided 2 out, it became pi over 2. So the phase shift is pi over 2. And inside here, if it's a minus, it's going to go right. If it's a plus, it's going to go left. Now, graphing in Math Lab. Let's look at this. So find the amplitude, period, and phase shift of the function, and then graph it. Be sure to label key points. Show at least 2 periods. So when we're looking here, the amplitude is 2. The period is 2 pi over 6. And the phase shift, remember we had to take that 6 out if we're going to find the phase shift, factor it out. And it is, when we divide this by 6, we get pi over 6 is the phase shift. All right, so you're going to go in here, and this is sine. So you're going to choose the sine icon and click on the origin. When you do, you're going to fill in the appropriate items here. All right, so the amplitude, we would slide over to 3. The period we put in as pi over 3. I'm going to make sure what we got. Okay. And the phase shift is pi over 6. And remember that you can use pi and it will put the pi icon there. We don't have a vertical shift, so we're okay. When you've got all that in, you can close the X, and it should graph the function correctly there, and you can hit save. Now, one more example. Write the equation of a sine function that has the following characteristics. We have an amplitude of 3, t is pi over 2, phi over w is 2. So I rewrote what I have. W is 2 pi over t. So I've got 2 pi over 2. That's how to figure that. There's that formula. And so when I do that, I have 2 pi over 1 times, flip this, 2 over pi. Pi's cancel out, and I end up with 4. So my W is going to be 4. The phi over W is equal to phi over 4, because my W I now know is 4. Phi over 4 is equal to 2. I got that here. And I'm coming up with my phi, because I need to fill in all these pieces in the function, the generic form. So that if I multiply 4 over there, I get 8. So now I have phi is 8, W is 4, and A is 3. So if I put it in this form, 3 goes in for A, 4 goes in for W, 8 is there. Or you could factor out the 4, and it could be written this way. So you may have to go backwards and write the equation given the characteristics. All right, let's go look at our problems. Again, we don't have a lot of them. We just have a few. All right, number 1. For the graph of y equals a sine wx minus phi, The number phi over W is called the phase shift. When you factor out that W, you get phi over W, and that is your phase shift. So that's a pull down menu, and you would choose phase shift. All right, number 2 is like we did an example. We had to find all of these things, and then we had to graph it. So 5 sine 3x minus pi. Well, the amplitude's easy. That is 5. The period is 2 pi over b, so that's 2 pi over 3, that number 3. The phase shift, if we factor out the 3, that means we divide the 3x by 3 and the pi by 3. So now our phase shift is pi over 3. So when you go to graph it, you're going to choose the sine icon. You're going to click on the origin, and then you would put in that the amplitude is 5, the period is 2 pi over 3, and the phase shift is pi over 3. And you should get this graph. 3, same idea. 2 sine pi x plus 5, and then a minus 2. So the amplitude is 2. The period, let's rewrite this thing. Let's factor out the pi. So 2 sine pi x plus 5 over pi minus 2. The period is 2 pi over pi, which reduces to 2. So there's your period. The phase shift is now 5 over pi. And because it's positive here, we are going to the opposite direction. So you'll put a negative pi over 5 over pi for your phase shift. That should work there. And here is our graph. And we had a vertical shift of down 2. So we are down here. Number 4. 4 tan 4x minus pi. Now, amplitude, if one exists, remember, tangent can't have an amplitude because its range is all real numbers. So anytime you're asked to find amplitude and you're talking about tan, the amplitude does not exist. If we rewrite this and factor out the 4, then we have the 4x divided by 4 leaves x. The pi divided by 4, we've got that. So the period is 2 pi over 4, which is pi over 2. The phase shift is now pi over 4. It was negative there. It'll be positive in your answer. On this, you are choosing the right graph. You can use your calculator, be in radian mode to graph it. And I would suggest using a window that matches this one. The X-min starts at pi over 8 and it goes to 5 pi over 8. Now I didn't do it. I didn't look at this one. That would give you enough room to see the pi over 2 one as well. And so we end up with this. Okay. Number 5. We're writing that equation. Remember, here is our generic form. We're told amplitude is 9, period is 9 pi, phase shift is negative 1 over 7. All right. The period is 2 pi over w. So 2 pi over w must equal 9 pi. We were given 9 pi. We'll cross multiply. We have 9 pi w equals 2 pi. We will divide by 9 pi, so w is equal to 2/9. So we've got that part. The phase shift is negative 1 over 7, and we now have our w, so we'll do phi over 2/9 equals negative 1 over 7. Cross multiply, negative 2/9 equals 7 phi. Divide by the 7, and you get negative 2 over 63 equals phi. I didn't do my little thing there. It's not theta. All right, so let's see if we can write that. We're filling in these parts. The amplitude is 9. We have sine. W is 2/9, so we have 2/9 x and then we came up with negative 260 over 63. So inside the equation, it will be positive. We came up with a negative value. It's always opposite of here. So that will be that. And that's really going to get you through the last section of chapter 6.